Wanted to do our notes today in a video, so please have your piece of paper out. Please make sure that everything shows up on the screen writes down. Today we're moving one step further, and we're going to be looking not just at a line of best fit, which is actually called least squares regression line, but we're also going to go ahead and take a look at an upper and lower bound, and you'll be working that on today as well in class, looking at the height of an early humanoid through information that you guys already know. So the date today is February 9th, and the first thing that we need to do in order to make this happen is we need to go ahead and we need some data. So what we're going to be looking at today is hours of sleep that a student gets the night before a math test and the math test score that they received on that specific day. So the very first thing that you need to do is input all of your data into Desmos or your graphing calculator. So your choice at this point, whichever one that you prefer to use. After you do that, you go ahead and find your line of best fit equation by typing in y sub 1 tilde mx sub 1 plus b. That's going to give you your line of best fit. I'm going to go ahead and do that for you on Desmos right now. So if we take a look at Desmos, here we have all of our data points that we've put in, and then we need to go ahead and change over here our graph settings to make sure that we have the correct domain and range. So we're going to go ahead and I look at my x values, and I see that my x values over here are between 5 and 10. So we're going to change our x values to be between 5 and 10. And then we're going to go ahead and we're going to change our y values. And if you look at our y values over here, they're between, it looks like the smallest is 75 and our biggest is 93. So we're going to go ahead and change that. And then we're going to go ahead and click on the graph settings and zoom out one. And there is our perfect graph. We're then going to make it do the line of best fit by typing in y, bringing up our keyboard, ABC. Y sub 1 is tilde mx sub 1, bring it back up, plus b. Now that we have this, we now officially know what our slope is. It's about 3, and we know what our y-intercept is. 61.3, and that's rounding to the nearest tenth. So now that we have that information in our calculator, we go ahead and we take a look at our next item, our next step. So our next step is step 2. We're going to go ahead and add your line of best fit on Desmos as a new line. After that, we're going to find the data point that's furthest away from the line of best fit. So let's go ahead and do that. So going back, we're going to go ahead and rewrite in a new tab. Y is equal to 3x plus 61.3. Take a look. We're a little off because we rounded it, but that's basically in the right direction. Now that we have this, we're going to go ahead and we're going to see which of these data points is furthest away from our line of best fit. And as you can tell, it looks like this point right here is the furthest away. So I'm going to go ahead and I'm going to change my intercept. In order to have it go through this point right here, I know that my y-intercept is going to need to be below that 61.3. So I'm going to just play and guess with my y-intercept until I find the perfect y-intercept that's going to make it go through my dot here that's furthest away. So let's go ahead and try, let's try 58. Okay, it's not quite through there, so we're going to go ahead and try 57. And 57 here, also too high, so we're going to try 56, getting closer. 55, I think we need a little further up. There we go, 55.1. This right here is called your lower bound. That means that all of the points go through at least that lower bound, and we're looking at the lowest a possible prediction would be. Our next step that we're going to be looking at is, every time we do this, we have to see all the points again. Sorry about that, ladies and gentlemen. So as we're going through, our next step after we found our data point that's furthest away from our line of best fit, and we change the value of the y-intercept so that your new line goes through that farthest away point, what we're looking at now for step 3 is we're finding the absolute value of the difference of the y-intercepts. What that means is we're going to subtract the y value, the y-intercept of your original line of best fit, and we're going to take the y-intercept of our new lower bound in this case, and we're going to subtract them, and we're going to see how far apart they are from one to the other. After we do that, we're going to take the y-intercept from your line of best fit, and we're going to subtract it from the original line of best fit if we already have an upper bound, or we're going to add it if we already have a lower bound. So let's go ahead and make that happen in Desmos. So I'm going to go ahead and subtract 61.3 from 55.1. So we're going to do that in our scientific calculator. So we have 55.3. That's our new y-intercept, and we're going to subtract 61.3, which is our original from our line of best fit. And I see that is, it's 55.1, sorry, 55.1 minus, we'll get this right, ladies and gentlemen, 55. It's a little early for me. I'm sitting here at 6 a.m. doing this for you guys. I hope that it's helpful. 55.1 minus 61.3. And as you can tell, it is a difference of 6.2. So I know that on Desmos, from here to here, there's a difference of 6.2. My bounds mean that I need an upper bound that's exactly 6.2 for my line of best fit as well. So I'm making an upper bound equation that has the same slope because we want them to be parallel, but for my y-intercept, I'm going to take my original y-intercept, 61.3, and I'm going to add to that, because I'm looking for the higher one, my difference between those original lines, and that was 6.2. So taking a look at that, I see that I have a y-intercept for my upper bound of 67.5. And this here, ladies and gentlemen, means that all of my points on my scatter plot are between my upper and lower bound. The reason that we do this is because we want a range of values. Instead of saying that my answer for my problem is going to be exactly this, you could get to say, and you get a little more accurate, it's going to be between these two numbers, and that allows us as a prediction to be a little bit more accurate instead of saying it's going to be this one specific answer. We're going to go ahead and finish up by putting this information into an actual problem that we're going to solve. So once again, we've gone through all of these steps. Hopefully you have those written down. You're going to add them to your drive and your website. And here's our problem we're going to solve with this. If a student sleeps for 7.5 hours, what score will they probably get on their math test? So originally, we'd find our line of best fit and use that for our prediction. So we have our line of best fit. We're going to plug 7.5, our x value, the number of hours we slept, and we're going to plug it into that equation. So here we go. 3 times 7.5 plus 61.3 gives me 22.5 plus 61.3. And I think we're going to score an 83.8% on the test. Now, once again, line of best fit gives you one answer. We want to use our other two equations to go ahead and get a range. So our range, we plug that same 7.5, but now we plug it into our new equations, our equation for our lower bound and our upper bound. Here's our upper bound, which gives me a score of 90%, and our lower bound gives me a score of 77.6. This allows me to give a range of possible scores a student who sleeps 7.5 hours might get. And so we know that they're going to probably get between 77.6 and 90% based on our data of student test scores and how much they slept the night before. Go ahead, take this, take a picture of it, put it in your website, and good luck with your activity today. Make sure you're working hard, make sure you're focused, make sure you're staying on task, and I will see you guys in a few days. Go Pirates! Have a great day, guys.